This is My Journey in Math, episode 4. Today we are going to look at addition. In the last episode we discussed the Hindu Arabic numeral system, which is the numeral system that we use today, and we counted some pretty big numbers and learned how to say big numbers. Today we are going to add these numbers, which is the first operation that we're going to learn in arithmetic. So why would you add two numbers? Let's say on Monday you made $7. And on Tuesday you made $5. And you wanted to know how much money total you made in both days. Well, you would add both of those up. Let's use the tally mark system to just visualize what we're doing here. So we had 7 on Monday and 5 on Tuesday, so we could say that we had $5, $10, $12, or that $7 plus $5 is $12. How about another example? Let's say you have a tree in your backyard. It grows oranges, and today you picked 6 oranges, and yesterday you picked 4 oranges. Again, we can use the tally mark system to see how many oranges we picked. One day we picked 6 oranges, and the next day we picked 4 oranges. Well, 6, 7, 8, 9 total would be 6 plus 4, which is 10 oranges. So those are simple examples of addition. There are many more examples of addition and things that we use today, but let's start learning how to compute larger numbers with addition. And to do this, we're going to introduce a concept called expanded notation, which sometimes is taught in the last lecture, but I wanted to bring it into this lecture. And in expanded notation, we're taking a number. Let's say we have 342, and we're going to express it as a sum. Now, a sum is 2 or more things added together. And to indicate addition, we use the plus symbol. So I want to represent this number as a sum of its place values. So what is each place value? We have ones, tens, hundreds. So we have 300 plus 4 tens plus 2 ones. So to expand a whole number into expanded notation, all we do is write it as a sum of its place values. So let's do another one just real quick, just so we can. Let's do 2,497. So we have ones, tens, hundreds, thousands. So we'll have 2,000 plus 4 hundreds plus 9 tens plus 7 ones. Okay, so it's this expanded notation that lets us use shortcuts for adding numbers, and we'll learn that in a minute. But first, I think it's very important that you memorize your addition facts. Okay, you shouldn't be going to a calculator to do 2 plus 3. Okay, you should know that 2 plus 3 is 5. Okay, so I'm going to write a basic chart. I'm going to teach you how to make a basic chart on the addition facts so that you can memorize it easier. So we're just going to take a row and columns here, and we're going to say these are plus. And we'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And if you want to put a grid in between each one of these, I'm not going to do that, but make sure they're spaced apart very well so that some of these get to be 2-digit numbers. Okay. So we're just going to fill in 0 plus 0 is 0, and as we go across, we're going to add 1 to, we're just going to count 4, 5, 6, 7, 8, 9. And then we're going to do the same thing at 1, and we're just going to count 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to start at 2, so we're just going to start, this number is going to be the same as this number because 1 plus 0 is 1. And then all we're going to do is count the rest of the column, or the rest of the row here. So it'll be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 3 plus 0 is 3. Start at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if you get bored, you could fill in downwards. All you're doing is counting 4, 5, 6, 7, 8, 9. And we're going to fill this in. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 7, 8. So all I'm doing is counting through this whole column. And you could do this for bigger numbers. I don't think there's really a reason to memorize past 9. But you could go on to 10, 11, I mean, as big as you want. But I strongly recommend. So this would be 10, 11, 10, 11, 12, 11, 12. You can count in either direction, up or down, right or down. It doesn't matter as long as you count up. 14, 15, 16, 17, 15, 16, 17, 18. So, okay, so we made this chart. Now, what does this do? Well, if I take say I want to add 5 plus 4, and where they meet is the answer 9. 6 plus 7 is 13. 8 plus 8 is 16. That's faster than doing it on a calculator, I think. 9 plus 8 is 17. 8 plus 6 is 14. Okay? So this is a good chart to practice your addition facts, and you could just make up your own quiz. You know, just make up numbers and see if you can add them all up and get them all right in a certain amount. You should probably be able to. You should be able to do 50 in under 2 minutes. That's a good goal. If you can't, that's okay. But you shouldn't be going to a calculator to add 5 plus 6. You should know 5 plus 6 is 11. Okay, so one good handy fact while we're here that I want to discuss about addition is that addition is what we call commutative. And it's not really so much the definition that I want you to memorize, it's what it means. What does it mean to be commutative? Well, when you commute is to go back and forth. So if you commute to work, you go to work and you come back home. So go back and forth. So the commutative property of addition will help you memorize these facts, because you really only have to memorize half of them, and I'll explain why in a minute. And that's because addition is commutative. That means if you add, say, A plus B, I know we're adding letters and you're like, oh gosh, A and B just could be any number, any of these numbers. It will always be the same as B plus A. And if you look it up, I mean, well, if you think about it, 7 and 5 is 12. Well, if you start at 5 and come down to 7 and do that first, it's the same as starting at 7 and coming down from 5. Okay, so if 5 plus 7 is equal to 7 plus 5. That's the commutative property, and that helps us later in algebra, and it will help us memorize these factors. And sometimes the commutative property of multiplication is a lot helpful. You'll see when we start multiplying big numbers that there's a lot less work if you do your multiplication a certain way than doing it a different way. So that's how to add numbers, basic numbers, and the basic properties of numbers. Let's talk about adding larger than the facts. And what I mean by that, we're going to add 2 or 3 digit numbers, or maybe 4 digit numbers. So let's add, we're going to call this adding 2 or more digit numbers. And I want to explain what we're doing when we do this, and then show you a shorter way of representing what we're doing. Okay, so let's say we're going to add 47 and 31. Okay, so we're going to add these two numbers. Well, 47 is 40 plus 7, and 31 is 30 plus 1 in expanded notation that we just learned about in the previous lecture. So we can add the columns here. 7 plus 1 is 8, and 40 plus 30 is 70. And the fact that we can do this is what we'll learn in a minute, is the fact that addition is associative, and I will discuss the associative property more in depth in a minute. But the fact that we can break these up into place values and add them is the fact that addition is associative. So we can use a simplified version of this without putting you shouldn't have to break it down into expanded notation every time. I just wanted to do this so that I could demonstrate what we're doing when we do it the shortcut way, which would be just to go add the ones column, which is 7 plus 1 is 8, and 4 plus 3 is 7. Now, of course, the question always comes up, what happens when when this is larger than 9? Let's look at an example like that. Let's say we have 39 and 47. Picking on 47 today. Okay, well, 39 is 30 plus 9, and 47 is 40 plus 7 in expanded notation. And when we add these, well, 9 plus 7 is 16. Well, 16 is 10 plus 6. So what we do when we carry is we're taking this 10 and putting it up here with the 10s, and we're leaving the 6 alone. So we could say 9 plus 7 is 16. We write down the 6, carry the 10 up here, and then add these, which would be 10 plus 30 is 40, plus 40 is 80. So 80 plus 6 would be the answer, 86. So let's look how we would do this in column notation. 9 plus 7 is 16, carry a 1, 1 plus 3 is 4, and 4 plus 4 is 8, 86. So we get the same answer. This is what you're actually doing, and this is the shorthand notation for doing that. Okay, so we've discussed how to add columns. Let's discuss a little bit more about what it means that addition is associative. And I think it is better to bring up these parentheses. Okay, everybody, this is kind of jumping ahead a little bit, but not so much. Whenever you see operations in parentheses, you're supposed to do them first. But what the fact that addition is associative, what that means is parentheses don't matter. So in other words, let's say we have 1 plus 7 plus 4. Okay? And we chose to add these two numbers first, and then in the next problem we're going to add the last two numbers first. So in this case, 1 plus 7 is 8, and then we have 8 plus 4 is 12. In this case, we have 7 plus 4 is 11, and 1 plus 11 is also 12. The associative property says when adding 3 or more numbers, it does not matter which numbers you add first. Okay, so in other words, if you only saw 1 plus 7 plus 4 like this, you could add 8 plus 4 and get 12, or you could add 11 plus 1 and get 12, or I could even get even crazier and add the outer side first. 5 plus 7 is also 12. Okay, so if you're only adding, it doesn't matter which numbers you add first. And let me show you an example of adding multiple numbers where this comes in handy. So, examples where this comes in handy. Let's add 31 and 68 and 39 and 72. Okay. Now, I picked these numbers because if you add straight down, you get 1 plus 8 is 9, and 9 plus 9 is 18, and 18 and 2 is 20. But if you look carefully, you could add these two first and get 10. 1 plus 9 is 10, and 8 plus 2 is 10. So if you add 1 plus 9 and 10, and 8 plus 2 is 10, you get 20. Okay, so if you look for patterns with 10, before you add, it might be easier. So we're going to write down the 0, carry the 2 to the tens place. Well, let's add these. We have, well, I can see that we have 3 plus 7 is 10, and 6 and 3 is 9, and 9 and 2 is 11. So if I add 10 and 11, I get 21. So we can write, if there's nowhere else to carry, we just write the digit 21. So if I add the numbers 31, 68, 39, and 72, I get 210. Let's look at some larger examples. Let's just make up some numbers. Everybody loves 9s. Okay, so we're going to add these two numbers, and this will close up our lecture on addition. Oh, almost. We have one more thing to look at. Okay, so 2 plus 9 is 11, so we're going to write the 1 in the ones place and carry a 1. And it's easier to add 1 plus 9 is 10 first, and 10 plus 4 is 14, so I write the 4 down and carry the 1 to the hundreds place. And again, I have 1 plus 9 is 10, and 10 plus 9 is 19, carry a 1. 1 plus 9 is 10, and 10 and 3 is 13, carry a 1. 1 plus 7 is 8, and 8 plus 1 is 9. There's no carrying there. And 4 plus 9 is 13. So let's write the commas where they're supposed to be, even though I didn't do that in the original problem. So if we add 473,942 with 919,999, the result is 1,393,941. Okay, so we've looked at some examples of adding. Let's talk about one last property that will become important later, and that is the identity. It's not really so much a property, but there's a number, and I want you to think about this. If I add a number to another number, it does not change the original sum. The sum and the original add-end are the same. So let's say if 3 plus what number will give me 3? I'll let you think about it for a minute. And the number is 0. So we call it 0 is the identity. And In other words, if you add this number to anything, you get the identical number you started with of addition. Okay. And I'm going to end with just a little bit of trivial vocabulary, because when most people start with the trivial vocabulary, these words are important because they're words that I'm going to use in future lectures, but they're kind of, it's boring. If I started addition, today we're going to learn addition. Well, the first number you add, the numbers you add together are called the add-ins. That, I try to start it off the lectures with something, an example where you're going to use addition, not with trivial vocabulary. So when you add two numbers, or two or more numbers, those numbers are called add-ins. And the result is the sum. Okay, so these are add-ins. These are add-ins. And the answer here, I like to box my answers, just the boxes here are sums. Okay, so that is lecture 4, or episode 4 of the first season of my journey in math. In the next lecture, we are going to discuss I hate to call it a cheat, but it's a shortcut that I've learned it in like 2nd or 3rd grade. A shortcut to checking math. Your arithmetic, we'll call it. In episode 5, and that shortcut is called casting out nines, and I hope to see you there. Until then, thanks for watching. If you liked the video, please throw me a thumbs up and subscribe for future videos, and we will see you very soon. Thank you for watching.